Okay, some more problems from section 5.1, and this is number 54. Another identity we want to verify. And it's pretty obvious we've got two terms. We're in pretty good shape here when we look at the structure of the left and the right. Two terms on the left, two terms on the right. The right's already in terms of sine and cosine, so I'm just going to try to get the left in terms of the sine and cosine. And that should be fairly doable. Okay? So over here I've got the sine. I'm already okay on the top, so the sine of theta, all divided by 1 minus, and the cotangent is the cosine of theta over the sine of theta. Those are your basic reciprocal properties you need to know, and your basic identities there. Okay, minus, and this is already in the cosine of theta, and this is going to be sine of theta all over the cosine of theta minus 1. Okay, so we got a couple of complex fractions, so we got to take care of these complex fractions. So we multiply the top and the bottom by the LCDs like we've done before. This is like over 1, so my least common denominator here is the sine, so I multiply the top and the bottom by the sine. And in this one, it's another complex fraction, and this is like over 1, so I multiply the top and the bottom by the cosine. That's the LCD. Okay? So we've done this before. First step, put everything in terms of sine and cosine. That's standard. That's SOP. What they call that standard operating procedure, SOP. Get everything in terms of sine and cosine, and then if we've got any complex fractions, simplify those, and the easiest way is to multiply the top and the bottom by the LCD. Sometimes we can just invert and multiply too. Sometimes that's easier. So when I multiply the top over here, I've got the sine squared. Okay, sine squared of theta. And on the bottom, that's going to be just sine of theta. And these are cancel, and that would be minus cosine of theta. Minus, and then cosine times cosine is cosine squared of theta. All over, and then cosine times that, that's going to be the sine of theta, and then this is going to be minus the cosine of theta. Alright. Now you're all saying, wow, it'd be nice if this was plus and I could make that a 1, but that's alright because there's another nice thing about this is when we have the sum, we know the sum's going to be 1, but when we have the difference, we actually have the difference of perfect squares. So that's going to work out okay anyway. So just be patient and make it one fraction, so we'll make it into one fraction. You might say, well, wait a minute, because we've got two terms over here and I've got two terms over here. Now I'm going to move away from this. Well, sometimes you have to move away to simplify, then move back. So just write two terms and you'll see what's going to happen here. So I've got one of these now. The sine of theta minus the cosine of theta. We're trying to get this plus over here. Now, again, like I said, if we had a plus here, that would be 1, but that's not going to help me get closer to this. But, again, we've got the difference of perfect squares, a squared minus b squared. The sine squared is a perfect square. The square root of the sine squared is just the sine of theta. And this is just a cosine of theta. So on the top of my fraction, if you look here again, on the top of your fraction, you have the product of the sum and difference of those little numbers. So I've got the sine of theta plus the cosine of theta, and I've got the sine of theta minus the cosine of theta. And on the bottom, what have I got? And I can think of that as times 1. And can I just cancel those? I surely can. And again, we're trying to show that this is equal to what? The sine of theta plus the cosine of theta And since these cancel, what do I have left? What I want to prove. And if you wanted to, you could even check it over here, because you could see when you cancel these, you've got this. All right? Okay, so I hope that helps on 54. Wasn't too bad. You just have to kind of go through it step by step and see how it works. Okay, let's take a look at 57. Maybe I can fit this in on this page here. Let's see if we can do this. Okay, that's 54. Let's take a look at 57. Here's 57. And we want to show that the cosine of theta minus the sine of theta squared plus the cosine of theta plus the sine of theta squared equals 2. So I think I'm going to get a whole bunch of Pythagorean identities out of this, so let's take a look and see how this works. So we're going to square these things out. So again, this is just algebra 1, a binomial squaring, or using the FOIL process or the method. That's what we're going to do. But these are binomials being squared, so they're just going to be trinomials. We know how the form goes, so let's write that out and see what happens. So when I square a binomial, remember x plus y squared is going to equal x squared plus 2xy plus y squared. Remember that? Okay, same idea. So the first term will be cosine squared, and then this is the SIG, and that goes in there. So in this case, it'd be minus. I should put plus or minus over here on this little formula. We had learned these when we squared these things out. That sign matches that. So in this case, it's going to be negative, and I've got two of those, 2 and cosine theta, sine theta, and then plus the second term squared, or plus the sine squared of theta. So that's this one. And then we're going to add that to this second one, so I'll put this sign in orange so you see where it comes from. And now we'll square this one out. I'll probably move over to this side a little bit. Hope that doesn't bother you. Cosine squared of theta plus 2 cosine theta sine theta plus the sine squared of theta equals, we don't know yet. And now if we look at these two terms here, don't those cancel? Yes, I got negative 2 cosine and sine, and positive 2 cosine sine, so those cancel out. So that's nice. And let's take a look at these, and I'm going to put these two together here. I'll put these two together here. So let's write those. So that'd be the sine squared of theta plus the cosine squared of theta. Okay. Plus, and then I'm going to put these two together. Sine squared of theta plus the cosine squared of theta. And what does this equal to? Well, that equals 1. And what's this equal to? 1. And what's 1 plus 1? 2. And there's your check. There's your verification. 1 plus 1 equals 2. And that's 57. Okay? Hope that helps.